This presentation is on text encryption with advanced encryption standard AES for near-field communication using Huffman compression. The presenters are as follows: Adeniji Oluwashola David, Olani Elias Akinola Ademola Oluwashola, and Olumide Afolabi of the Department of Computer Science. Below are the agenda for the presentation. Number 1, introduction, problem statements, review from literatures, methodology, result and discussion of personal identifiable information must not be compromised with the required data encryption. So the focus of the study is to mitigate against intrusion in the levels of communication transaction between the card and the reader. Privacy and authentication are the major concern in radio frequency identification system. The protocol implementation in transfer of ownership in mobile communication normally consider handheld components from reader to backend. So to secure and to provide counterfeit measure transaction of RFID system where tasked with limited resources is very important. New options mode of ownership transfer have been developed, which has led to improvements and maintenance of specific application. This application varies from ubiquitous computing, logistic management, and traceability. The concept of cryptanalysis has been implemented to some of these protocols, such as EPSC1G2 standard, thereby analyzing the level of security. The focus of such algorithm when tested is to reduce collision and use time division multiplexing. The implication of this is majorly to correct robust protocol error correction codes. So encryption as a technology will only protect sensitive data. Most algorithms used in encryption combine both public. Basically, encryption usually hides sensitive data of users, which use information as a retrieval process. So for RAD such as 16 identical stages for processing the permutation of plain text are normally used in AES. So advanced encryption standard AES encrypts only 128 bits in one iteration. So AES is fast, flexible, it can crack Cepher. Doing operation require use of different multiple key. So the problem statement in this study is Huffman code can be accessed, both code word lists with encoded bits in order to decode the message. So in this way, improper error correction algorithm with encoded bits can be damaged, resulting to total loss of information. So our interest is how can we mitigate against some of these damage loss of information. So however, codes like word lists and code bits sent to the receiver are normally at high transmission time. So there is need for us to provide a countermeasure techniques that can secure and fix the damaged encoded bit. During the course of this study, we have reviewed some various papers, and some of the papers give us an insight on the direction to follow. From paper 1, we try to categorize lossless compression algorithm, canonical Huffman coding associated with a given system. But in this review, we discover that there are limited computational and energy resources, which can lead to low complexity and high compression efficiency in literature 1 and 2. Systematic key block cipher algorithm were also developed, thereby describing the analysis of several algorithms. Huffman coding normally is a concept that determines the frequency of occurrence of a data item, which may differ according to the type of data, which may be video, image, text, or other format investigated. The strategy attempts to detect only known attack based on predefined attack characteristics were proposed in literature 8. So a secure text encryption with near field communication using Huffman compression were also proposed. Our character proximity for RFID smart certificate system was designed to curb forgery. The center of system, it implements the entity business group and makes sure data is securely accessed. Infrastructure layer handles external concern on the database, calling an external endpoint and sending. And the middleware is the store stage of this design, which consists of repository, logic, security, and interface. The repository is a storage mechanism that hosts both structured and unstructured information. During the simulation, the logic layer ensures that the information created or updated are in conformity with the set of canonical rules. So the logic layer ensures integrity. Below are the logic layer in the security, which ensures information of the system, most importantly for being secure from an unauthorized action and data theft. So the security control anti-collusion feature, that's mutual pass authentication and random ID support, which are injection of the GUI and the API, they are combined together to build the interface. So the simulation was run and it was implemented on a reader ICAI 1311, which supports both Bluetooth and USB 2.0 connection. The near field communication card is the MiFi. The diagram below shows the algorithm for the model. In this model, the first step is to check the AES mode. After checking the AES mode, configuration of unique character is being registered. This information are pulled to write the payload to the buffer. If that is done, it goes to the ACM mode, but if not, it goes to the configuration of unique character again to start the process. So if the AES mode is done, it generates unique character mode, and after the generation of unique character mode, it will generate subkey to the unique character mode, and it will output the results. After outputting the result, it will write to the buffer, and it will send the interrupt to unique character for registration, and the whole information process. So this particular diagram gives us the simulation of the developed model, showing us the interface of how the configuration of how the simulation present to us that there is no availability of the card. Second mode, the card has been detected and is showing us the active protocol where T to 0. Results and discussion. Our findings from this study shows that the investigation are very important to entropy, in which we predicted how difficult a given password will be cracked through a bootstrap or guessing. So we have four important equations: SU of C1, we have LK of K, and we have Z of LCK, and we have the entropy of log 2 of Z. So these four equations were used, and it is important that at last one character is chosen from each of the three sets. This 6 character key is further separated and hashed for better security. The higher the entropy of initial text, the more accommodating the output size to change the value of what? Of n. So there is also a direction correlation between the value of n and the output size, as seen in figure 2 below. When AES entropy byte is equals to 50, we can see the trend. We have the output size and we have the unique character. So here the indication here shows that the complexity of symbol by symbol coding in the result is determined for factors responsible for performance, and the unique character increases in the output as present as the compression reduces. We went to other tests to test when n equals to 100, and in this experiment we discovered that the outputs of the unit size and the number of unique characters also increases as the number of the sizes also increases. So we also test for the third experiment where n equals to 150, and the result is depicted this graph. When n equals to 50, we can deduce from this graph that the character of when n equals to 50, the CBN and CBN at AES are running mode, and we have the CBN optimal at 0.13 ms microseconds, and we have the ECB at 0.12 microseconds at optimality. So this shows that the symbol by symbol restriction has dropped with a known input distribution. So we consider when n equals to 100, and from this analysis we discover that AES running on the mode was 0.13 microseconds at CBN optimal, and ECB was 0.05 microseconds. Also a single code may be insufficient for this optimality. And we went further to test for the third experiment when n equals to 150, and from there we were able to deduce that the AES running mode is 0.025 microseconds at CBC optimal, and ECB 0.05 microseconds, and also a single code may be insufficient for this optimality. And the last test is when n equals to 200, and which was conducted, and the unique character at 0.5 for AES running mode of 0.023 microseconds at CBC optimal, and ECB 0.023 at optimal. Now, the important performance determinant is the real time required for inscription. AES was implemented in both ECB and CBC cipher mode to compare their performances. So the symbol by symbol server mode can determine the correlation running time, thereby protecting the level of communication transaction between the. We came up with the conclusion that redundancy and pattern of stored content with less space is assured. Unique character has different location on the tree. The character may not represent the same number of bits length. The use of application protocol data unit APDU as a medium of communication unit between a smart card reader and a smart card contain mandatory byte header. So the developed model in this social using AES technique is to secure and fix the unique number character at different location on the tree with N denoted in the simulation. So the symbol by symbol cipher mode can determine the correlation running time, thereby protecting the level of communication transaction between the card and the reader. So we want to specially acknowledge this research which is being conducted at the Department of Computer Science, University of Ibadan. For listening, the references are below.